And I know these seem like really obvious, but I just want to go through some basic field axioms just to show you how these would work and make a comment about proofs, because I think there's something nice to be said about proofs in here. So let's prove the first part. I think this is pretty straightforward, so I'm not going to slow down too much, but if you guys need me to slow down, tell me. But so assume again, x plus y equals x plus z. Well, so what we want to prove y equals z, so what should we probably do? Yeah, well, you want to subtract x because we're going to be jerks for right now. I promise I'll get over it by like Wednesday. I'm going to add the additive inverse of x to both sides. So because these are equal, we can add, minus x to both sides. Which gives us, and then we simplify, you can do commutative. I mean, heck, I don't really care. I'm just going to make, like, I wrote it down, you add the additive inverse, you use a commutative property, or maybe you add it on the left, and then you associate a property or whatever, it doesn't matter. But the point is, you get back that y equals 8. Alright? I'm not going to be a stickler on all this stuff because this is an algebra class. But the point is y equals z, great, everything's easy. But the reason I wanted to do this is now let's try to prove b. How should I prove b? Right. See, this is the first time I'm going to do something. Something I'm going to do a lot. And this is like, I've already proven this really nice fact. I don't prove things just so I can put them on my mantelpiece and show them up. I prove them so I can use them. And the point is, actually, there's a way to prove b in one line as a consequence of a. So instead of going through, like, if I had done this correctly, add the additive inverse, use the commutative property, use the associative property, cancel 0 plus, there'd be like 10 steps. But I don't need to do that because I can just say, we know x plus y equals, is it y? Did I write y? X plus y equals x, equals x. But we already know from property for x equals x plus 0. So by a, y equals 0. Right? And the reason I want to show you this is that, maybe I'll save it for that. No, I'll tell it that joke now. Bad joke. It's just, I tell it every semester because it makes a good point. This is an easy example of it. But, so there's this really bad joke about this mathematician who joins the reserve firefighters or something. He's getting trained by a firefighter how to be a firefighter. And so he takes him to an alley and the trash can's on fire. And he goes, okay, I'm going to explain to you how to do this. He plugs in the hose, turns on the water, sprays down the fire, fire's out. Great. So then he takes him to another alley, the trash can's on fire. Yes, and what do you do? Well, the mathematician paid very good attention, is able to repeat it, plugs in the hose, turns on the water, puts out the fire. Great. Here's the bad punchline. So the mathematician now he takes him to an alley that doesn't have the trash can on fire. It's a completely normal alley. And he asks him, what do you do? He grabs gas, grabs matches, lights the trash can on fire, plugs in the hose, turns on the water, puts out the fire. Now, it's a very bad joke. It's embarrassing for me to tell, but the reason I tell it is it says something about math that is like the most important thing you can learn about math. And that's that the way we think, the way mathematicians think, and the way we want you to think is we don't solve one problem by itself each time. We take a problem and make it into a problem we know how to solve. And then do it. Which is exactly what I did here. I took this problem. Now, I could have gone through all these stupid axioms and gotten the same result. But I already knew this result, so I made this look like the previous problem, and then kicked it out. Does that make sense? So I have a question. Can anybody see how I'm going to prove part C? So let's prove continued for C. How am I going to prove part C? Well, we still have x. I know I'm leaving out stuff. I'm feeling like I'm falling behind. We have x plus y equals 0. What am I going to do? Yeah, we can write this as x plus minus x. Yeah, hey guys, in about 5 minutes, I'm going to just start writing x minus x. Just so you know, I'm being precise right now. Which immediately gives us, again, by part A, that y equals minus x. Okay? But I just wanted to point out a couple things. So this is, if you've taken other classes from me, you've seen other proofs of this. What did we really prove here? We proved the additive identity is unique. There is only one zero. Right? There can't be two things that send everything to itself. Does that make sense? Because we said if something else does it, it's zero. And what did we prove here? That's right. Additive inverse is unique. Is unique. So this is different than the typical uniqueness proof I will give. At some point I'll probably give a real uniqueness proof. We'll go over how to do that. This is the additive inverse. Is unique. Oh god, too many quotes. Whatever. Okay, great. And what about the last guy? So how are we going to prove the last guy? Well, how do you prove, so what do we want to prove here? Well, we want to prove that x is the additive inverse of minus x. So that's pretty straightforward, right? Because we know x plus minus x is equal to 0. But you can always just, just to be precise, this is just that. Right? But at the same time, or maybe I'll put the 0 here. Okay? But at the same time, 0 is equal to minus x plus minus x. Right? So now we use a again. These two are the same, so x was equal to minus x. I know this is boring. See, this is what I was saying about today's lecture being kind of slow, but I think you should really remember today's lecture because you'll appreciate it when things aren't this slow. But I just wanted to prove these basic facts for you guys. Great. So actually on homework, I'm not even going to write it on the board because I'm running out of time, but on homework there's an equivalent version of all these things for multiplication. Like if x times y equals x times z, and x and y and z are not 0, then x equals, if x times y equals x times z and x is not 0. It's the same exact statement except multiplication instead of addition and all these things. And x is not 0 is written everywhere. Okay? And that's actually on your homework, so you get to prove that. Alright? Are we good? Are there questions? Right, I'm not going to do that property yet, I've had it already. Oh, you still have to do this proposition. 5 more propositions. I hate you, really. Yeah, because he does all these like really straightforward propositions and then throws out like proof that every real number has an n, every positive real number has an nth root. And that proof is like, it took me like a good 20 minutes to like, I'm basically, when I present it tomorrow, going to give like 3 or 4 lemmas before I prove it. Because he didn't write the lemmas, he just assumed you guys have to know all these facts. I go over it. So another proposition, so this time we're going to have 0 times x equals f equals 0. If x is not 0, y is not 0, x, y is not 0. C. Minus x times y equals minus xy equals x minus y. These are actually a little tougher, so we're going to have to cut it using this calculator. Minus x times minus y equals xy. And then this is one I just drew in for myself. It's not actually in the book. I just wanted to see if you guys could do this. So what I'm going to do is I'm going to go through the first 4 parts, and I'm going to ask you guys, maybe working with your neighbors, to prove letter E. Or your neighbors, I don't really care how many you work together. Now we have to prove all these stupid things. So prove that I'm not the racist structure. Okay. So this one's actually probably the easiest. But there's this really nice trick usually with working with zeros. So I want to prove 0 times x is equal to 0. Well, what you do is you realize that 0 times x by the distributive property is really 0 plus 0 times x. Well, not by the distributive, this is first by the additive identity property. Yep, because 0 plus 0 must be 0. The additive identity. Which tells us that this is by the distributive property, so this is, I don't know, this is what? A4. And then 0 times x plus 0 times x, and this is by the distributive property. And then you're like, okay, cool. Well, this equals that. What do you think I should do to finish this proof? Well, I have 0 times x plus 0 times x equals 0 times x. But I can just think of this as 0 times x plus 0. And I'm tired of saying the word 0. But does that make sense? And now by what we already proved, these two are, if we get the cancellation, this implies that 0 times x is 0. Does that make sense? Fast, I know. The point is, you got this string, right? So we have that this is equal to one of these, so we just think of these one of these